Hello everyone, my name is Jelson Joseph and I am an AI engineer, and today I'm going to start a project, and this is the first day, day one, where I'll be combining two of my interests, AI and football, and basically try creating something. So let's start. So this is this project is in simple word, this PPT is made by Notebook LM, and there will be loads of high terms. I'll break it down simple in simple words. Let's first get a quick overview of the PPT. So what we are building is a voice activated AI copilot for football analyst, not analytics, football analyst. So what is the bottleneck? Means whom are we building for? We have to first define it. That we are building it for mostly football analysts who have to manage millions of data points uh, by which are blocked by many UI dropdowns and dense spreadsheets. Basically, football data is very dense, and we have to condense it somehow into an interactive, easy to use way. So time to insight select a modularity for all this there. You can read through it. I'll just go a quick overview. Okay. So what's the vision? The vision is to create a Jarvis type illusion. Yeah, we are trying to creating an AI assistant like Friday or Jarvis, which is shown in the animal series. So uh, what does it do? In simple words, here's look at the example. I'll tell the system, show me um Salah's shots from outside the box after the halftime, after the 75th minute um, against Chelsea. So it's a query, but we are saying it in a layman's language. So there has to be some kind of processing to convert that raw language into SQL queries or structured queries and give it to the system, and the system will have in turn build some visualizations on top of that which we can understand it. So that's the main goal, and do so the interactions in real time, so there is kind of a good user experience. Yeah. So yeah, if you can read through it, this also. So yeah. um and yeah, so I want to talk about the data here quite a bit. So yeah, I'll just go through here. Okay. So so now let's start. Okay. So first, what we'll do is we'll try to understand how the data is formed, or we have to get a bit idea about the data, because without data here, it will be difficult to understand what we are building exactly, or like not that exactly, but how what we will use to build some the project. So it will be difficult. So we have to clarify it. Okay. First is we have to define some scopes. There are tons of competitions in the world, and I'm condensing it to Europe. Firstly, second is I'm giving it to I thought of one season. Okay, why these two? Because Europe uh, has host the best five leagues of football: the Premier League, La Liga, Bundesliga, Liga 1, and Serie A. And I'm focusing on the best league in the world, Premier League, and season is 24-25. We are trying to get a data on the most recent one season. So yeah, this is the first scope. Second, okay, uh, the second thing is trying to understand what types of data are there. So as by doing, I was trying to understand like the various kind of data that comes into play here uh, in football. There are tons. Betting will be there. There will be scout and recruitment, scouting new players, and there will be like physical training. There will be match related data. There will be news. There will be transfers, etc. Okay, we are only scoping ourselves. What will be our scope is tactical analysis and player analysis. So we are scoping it only to um, match related data. Okay, so what will be match related data? Anything that happens inside the 90-minute or plus time period frame. Okay, anything that happens between this during the game time, data game time will be our scope of data. Okay, so yeah, and there is, I found out that now we have defined the scope. There's two types of data. Okay, structured data and unstructured data. Pardon my handwriting, I'm just using a mouse here. RET. Okay, structured data is any data. It's my terminologies, it may differ, but I found it after tons of research. I found its common definition is anything that can be represented in the form of like structured rows and tables or JSON files. Okay, because um, as per the scale of data, as per the complexity of the data, the scale can be enormously large. In a single game event, there can be tons of millions of data points, 600, 1 million to 600 million data points. It's not exaggerated. There happens. It happens. Okay. Now, which kind of data holds that many kind of that and much more enormous amount of points? We have to. That will tell us. For that, we have to know about the tiers of unstructured data. Okay, there are five tiers as per how what I research and how I group it into tier one, tier two, tier three, tier four, tier five. And like we climb up the ladder from five to one. Five is easy to access. Uh, like I'll show it to log kind of way. It's easy to access, and this is the log kind of data, very secure and like very hard to get, and like will hold legal consequences. I mean, it's basically private data of players. We cannot access them. Yeah. So tier five will be max fixtures and all. Max fixtures who won a match, scores, etc. Tier four will be like uh, common metrics like um, expected goals, uh, expected trade, common metrics. Yeah, these are all football related metrics here. These are quantifiable and measured through statistical means. And yeah, so this is that. Tier three will be um, like, let's go back a bit. Here, yeah, see, tier four, as I said, detailed desired advanced analytics calculating expected goals, expected assists. Tier 3 will be discrete event data of every pass, shot, and duel enriched with 50 specific context. Like that. That's not necessary, but discrete event data means what happened on the pitch, how many passes was played, how many tackles were done, how many yellow cards, how many red cards, how many saves, how many corner kicks, set pieces, etc. Event data. This is what happens. Okay. So tier 3 is event data. Now, okay, this is one. Now comes tier two. Okay, tier two, what you find is continuous spatial tracking. It's like real tracking of every 22 players and including the ball during the 90 period timeline or the game play. Means at one point did the ball travel from player A, Salah, to Van Dijk in Liverpool. I'm talking about Liverpool. At from which X point, their spatial geometry will be used, XYZ coordinates, XY or XYZ coordinates. This will be used. Okay. Yeah. And yes, this is what I was talking about, the like 600 million points, because you are calculating every distance the players travel, every kind of passes taken, every kind of dribbles made. So you are tracking everything during the 90 months, and there are millions of like uh, events that happens. You're basically, I think they, if I'm not wrong, they calculate 25 uh, hertz of events per frames, or I think per second of individual player. So you can see if you scale up how much scale it comes to. Okay, and the last one is tier one data. This is the most secure data of players, because you are calculating how much physical load the player endured, how much, what was his heart condition, what was his acceleration, deceleration, what was his sprint timing, what was his uh, load on the left leg, what was his load on the uh, muscles, tendons, etc. These are very private data of the individual players, and you calculate through there is high speed cameras for this. Companies like Okta or Huddle, I think they calculate this. HUDL. Search it up once later. OPTA and HUDL, and what they do is um, they basically uh, try to calculate 22 joint points of the player. Okay, 22 joint point, elbow, hand movements, shoulder movements of every individual player on the field. So through that, they will get a better understanding of what the player intended to do, and etc. How was his shot taken, etc. Basically, many uses will be there: offside traps, fouls, VR systems. I think that's how it works. I didn't research much on that, so disclaimer. Yeah, so basically this is the scope of data. Okay, now, yeah, that's it. We'll see next later. I will explain the other things. Okay, so the next thing that we discuss or focus on is, we have gone through structured data, we have gone through the scope, we have gone through like which leagues we are taking. Okay, so the next thing is the second part of data, that is unstructured data. Unstructured data, what it's my terminologies. Okay, I've researched it and like uh, put it through for my understanding. I hope, I think it's good, but it's not a standard definition, so take it with a grain of salt. Yeah, so anyways, I'll discuss it here. I'll just clear it up all. Okay, yeah, so what unstructured data what I label unstructured data is anything that is not enough difficult to be represented in the form of structured rows and tables, okay, or JSON files, key value pairs cannot be represented. It's difficult this way. This is what I term is unstructured data, and like the core 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 examples. Um, sorry, just one. The core examples would be uh, long articles of text, long articles, or any content that is having long body of text. Okay, it can be news reports, it can be match analysis, tactical breakdowns, uh, team analysis, heat map analysis, etc. Anything. It can be those, but it's written in block format or uh, anything. It can even be video transcripts, video match breakdowns. We can take that transcript and convert it into text articles. That's what should be done. Convert to text and audio. This is also convertible to text. Audio commentaries. I'm talking about commentaries. It can be also ultimately converted to text. Okay. So this is one form of unstructured data. That is any data that can be converted to text, long form of text. Now, why? Why is this important? Why? Because we are using LLMs here. We can incorporate this thing to build RAG systems here. Okay. I see one use case is the power of RAG systems here. So that's one use case. And like since because intermediary we are always will always be using one LLM, and texts are more easier to understand than SQL queries. Finger cross, okay, I'm not sure, but I'm assuming that text is much more closer or familiar with LLMs, that's all, than structured data. So that's why I find it one interesting thing is the use of text, the many possibilities of using text data as unstructured data. Okay, so um, yeah. So next thing is uh, next type of unstructured semi-structured data would be videos, video feeds. Okay, we would not be scoping to this, but this is just to be understood that this is like most used data, like for real-time tagging. And we see uh, in video breakdowns, we see a player being their tactical lens being drawn, uh, 3v2 formations, 3v1 situations, like ball passes through line breaks, defensive formations. We have to draw breakthrough lines to that. All that is done in video feeds. And we are not scoping to that for now because due to hardware limitations. But just to be considered that it's there's also one use case of that. This unstructured data. It's my definitions, okay? And yeah, so there's semi-structured also, but I have not delved much into it. But this is what I understand is like scraping uh, XML kind of data or something. I'm not sure, so I won't go into this much. But what I found is structured and unstructured data, two main use cases. Okay, so yeah, see, tactical analysis. This is the first novel increasing like unstructured data, context, and proof. We can give video feeds as a proof and OTT commentary as the context. It can be combined and a powerful narrative can be built. Okay, so that's one use cases. Oh, but unfortunately, we won't be going to video feeds because hardware limitations. We'll try something else, but not that. Okay, so yeah.